Lesson number 2. Set of numbers and types of set. Some sets are so important that we use special letters to denote them. A. Set of natural numbers. This set is denoted by capital letter N, and it consists of the element 0, 1, 2, 3, and so on. B. Set of positive integers. This set is denoted by capital letter Z plus, and it consists of the element 1, 2, 3, and so on. C. Set of negative integers. This set is denoted by Z minus, and it consists of the element -1, -2, -3, and so on. D. Set of integers. This set is denoted by Z, and it consists of the element 0, plus -1, plus -2, plus -3, and so on. E. Set of rational numbers. The set of rational numbers is denoted by capital letter Q, and it is the set of all R such that R is equal to M over N, where M and N are elements of Z, and N is not equal to 0. That is, the set of rational number Q is the set of all fractions M over N. F. The set of irrational numbers. The set of irrational numbers is denoted by QC or Q prime. That is the set of all R such that R is not equal to M over N, where M and N are integers. That's the set of numbers that cannot be written as a fraction, is the set of irrational numbers. G. The set of real numbers. This set is usually denoted by capital letter R, and it is the combination of the set of rational numbers and the set of irrational numbers. H. The set of complex numbers. The set of complex numbers is denoted by capital letter Z, and it is a set of all Z such that Z is equal to X plus IY, where X and Y are elements of R, and I is an imaginary unit defined as square root of -1. Types of set. A. Null set. A null, or we call it empty set, is the set that has no element. It is denoted by the symbol phi. This symbol is called phi, or a curly bracket without something inside it. Example 1. Number 1. Phi is equal to the set of all x such that x squared plus 1 is equal to 0, and x is a real number. This set is empty because there is no real number whose square plus 1 will give us 0. 2. The set of all x such that x squared minus 16 is equal to 0, and 3x minus 9 is equal to 0. This set is empty because there is no number x that will satisfy these two properties at the same time. Take for instance the number 3. If you put x equal to 3 here, 3 times 3 is 9, and 9 minus 9 is equal to 0. This property is satisfied. But that 3 will not satisfy this other property, because 3 squared is 9, and 9 minus 16 is minus 7, which is not equal to 0. Hence, this set is empty. 3. The set of all x such that x is not equal to x is also an empty set, because there is no number that is not equal to itself. The second type of set we shall discuss here is singleton set. A singleton set is a set containing only one element. Example number 2. 1. The set A containing only 0 as its element is a singleton set. 2. The set B equal to the set of all x such that 2x plus 6 is equal to 0 is a singleton set, because it is only one number x that can satisfy this equation, and that number is minus 3, because 2 times minus 3 is minus 6, plus 6 will give us 0. So the set B contains the element minus 3. Hence, it is a singleton set. The third type of set we shall discuss here is what we call universal set. In any problem situation involving set, the set that contains all other sets is what we call the universal set. It is the largest of all the sets, and it is denoted by capital letter U. D. Countable and uncountable set. A countable set is the set whose element can be put into one-to-one correspondence with a set of positive integers. A set which is not countable is uncountable. Example 4. The set n of natural numbers, the set z plus of positive integers, the set z minus of negative integers, and the set z of integers are all countable infinite set. 2. The set q of rational numbers, the set qc of irrational numbers, the set r of real numbers, and the set c of complex numbers are all uncountable sets. On your own, say whether each of the following set is a null set or not. 1. A. The set of all x such that x squared plus 1 is equal to 0. 2. The set B of all x such that x squared plus 1 is equal to 0 and x is element of R. 3. The set P of all x such that x squared minus 4x plus 3 is equal to 0 and x is element of C. 4. The set M of all m such that m is a month of the year having 27 days. Say true or false. 1. 4 is element of C. 2. 7 is element of Q. 3. Square root of minus 9 is element of R. 4. 5 over 4 is element of Q prime.